Hello, let's continue with part 2 of our chemical bonding worksheet 2, the structure questions. Okay, in the previous part, we looked at the dot and cross diagrams of covalent molecules. So, okay, question 2, we have an element Y, so this is an unknown element. They tell you it has an electronic structure of 2.8.4. Part A suggests the chemical formula of the compound formed between element Y and chlorine. So on the side, as you can see, I always will do this little working through of the electronic configuration. So Y is 2.8.4. Chlorine from the periodic table, we will know that it's 2.8.7. Okay, so we would know that Y, element Y will need to share 4 electrons, whereas for chlorine, it just needs to share 1 electron, right? So in this case, then on the side, we can roughly work out that element Y will form such a compound, a covalent compound, together with chlorine. So this is slightly similar to methane, right? Something that rather basic molecule that we have learned how to draw previously. So part A, the answer will be YCl4. Okay. Part B, draw a dot and cross diagram of the compound YCl4 from the previous part. Show only the outer shell electrons. Okay, so if you look at Y, which is in the middle, it has 4 of its own electrons represented by the dot. And then chlorine has 7 of its own electrons represented by the cross. And it is sharing 1 of that with Y. Okay, so and then once you're done with the diagram, one look you can also tell that around the chlorine atom there are 8 electrons, stable octet. Likewise, that for Y also stable octet. Let's continue with part C. Using structure and bonding, explain why this compound has low melting and boiling points. So if you look at part C and D, similar to our worksheet 1, right, for ionic bonding, you would see that in terms of the format, it's pretty similar, right? So these two parts of the question, you are trying to use structure and bonding to explain why covalent molecules have their specific physical properties of the low melting boiling points, as well as the inability to conduct electricity in any state. Okay. So do note that there are some changes that you need to make. There's a little typo there. It's not element, but it's compound. Okay, so please make that change on your worksheet as well. So part C, the compound has a simple molecular structure, so that's addressing the structure bit. As such, there is just little energy needed to overcome these weak intermolecular forces of attraction between the YCl4 molecules. Okay, so I want to point out a few parts in this explanation here. So number one, this forces of attraction is weak intermolecular force of attraction. Okay, so this word inter, right? Inter means between, right? So you see here between the YCl4 molecules. So it's like when we play inter-class competition, inter-school competition, it's between classes, between schools. So this term intermolecular force of attraction refers to that is between molecules. So this one is be very careful because students might often get confused and write other things like atoms or ions. Okay, so at this point you got to be very alert and careful about what exact particle you're talking about. Okay, so over here definitely you shouldn't mention anything about ions because this is covalent bonding, nothing to do with ions. So please take note of that. Okay, so since these weak intermolecular force of attraction is so easy to overcome, therefore covalent molecules have low melting and boiling points. Then part D, explain if this compound is able to conduct electricity. The answer is no. The compound is unable to conduct electricity. In fact, in all states, right? Be it in the solid state, liquid state, or gaseous state, it cannot conduct electricity. Reason is because it does not have any free moving ions right? No ions because again, this is covalent, nothing to do with ionic bonding at all. So there's no free moving ions. Likewise, there is also no free moving electrons, right? If you think about it, the electrons are being shared, they are being so-called in a way kept in that their electron shells, right? They are not being able to move freely on its own. So therefore, in this case of covalent molecules, they do not have any charge carriers. Okay, so yeah, so as such, they are not able to conduct electricity. Moving on to question 3, the diagram below represents a molecule of methane CH4. Part A, is methane an element, compound, or a mixture? Answer is compound. As you can see from the diagram itself, the different sized atoms, or rather different sized circles, represents different atoms. So over here, since you have two different elements chemically combined together in a covalent bond, here it's very clear that methane is a compound. Okay. Part B, label on the diagram with an arrow labeled B to show the position of a carbon atom. Yeah, so here the chemical formula of CH4, clearly there's only one atom of carbon and four atoms of hydrogen. So just based on the size of the circles, you will be able to tell that this that I'm labeling here with a B and an arrow is carbon. Part C, state the type of bond labeled A. So this is a covalent bond, right? So remember, for covalent bonding, it only happens between non-metals. So I mean, already in the diagram, it's very obvious that it's covalent bond, but another way of just cross-checking is to look at the chemical formula, which is consists of carbon and hydrogen, right? And these two elements are non-metals. So that would be an added confirmation that the bonding here is definitely a covalent bond. Last question, question 4. Phosphorus has the electronic configuration of 2.8.5. It forms a gaseous compound with hydrogen. Okay, so if we just look at the question, right, you notice that it makes sense. And as you do more and more questions, you realize that really the question will give you a lot of clue lah. So you don't have to be worried about whether you'll be confused with ionic or covalent bonding. So for instance, let's say phosphorus, you know that it's a nonmetal, and then they tell you that it reacts with hydrogen, also a nonmetal, right? So straight away you know that it's forming a covalent compound. Then you notice also it tells you this information that it forms a gaseous compound. So if you can recall the physical properties of both ionic and covalent compounds, they're very different. For ionic compounds, they have high melting and boiling point because they have this strong electrostatic force of attraction between the ions, right? And then for covalent, it's the other way around, and a bit different as well. The weak intermolecular force of attraction is easy to overcome. Therefore, the low melting and boiling point. So that's why over here, it will exist as a gaseous compound at room temperature and pressure because of the low melting boiling point, right? Yeah. So, okay, part A, name the type of bonds present in this gaseous compound. Okay, so it's covalent bond. Part B, draw a dot and cross diagram to show the bonding of a molecule of this gaseous compound. Okay, so again at the side, we work out the electronic configuration. We know that each phosphorus atom will need to share 3 electrons because it is 3 more electrons away from stable octet, and hydrogen will be sharing 1. So this is your diagram. Over here, they did not mention just to show valence, so we have to show all electrons. Okay, so this is very similar to ammonia molecule that we have drawn before, right? So in fact, subsequently when we have the chapter on the periodic table, you will also be able to better appreciate this. You notice that phosphorus is in the same group as nitrogen, right? It is just one period below nitrogen, just have one more inner shell over here, this fully filled second shell. And as such, you notice that if we are just talking about, we have always been talking about just valence shells, right, in the valence electrons, or rather the valence electrons in the valence shell. So you notice that in terms of the shape of the molecule and the bonding, for pH3, the one that we are drawing here, is actually exactly the same as ammonia. In fact, if we were to just draw the outer shell electrons, it will look exactly the same as ammonia, just that the middle symbol here, instead of P, or rather instead of N, it would be P lah. Okay. Yeah, so okay then, the last part of this question, what is the chemical formula of this compound pH3? Okay, so that would conclude our chemical bonding worksheet 2. Have a good June holiday. We shall see you back in school in term 3, hopefully. Goodbye.